Welcome to Daikin web-based training. When a problem occurs in an air conditioner, a malfunction code will be displayed on the remote controller in order to communicate what the nature of the malfunction is to the user. Based on this malfunction code, the service person is able to diagnose the problem when he comes to repair the air conditioner. This course will provide you with the opportunity to learn how to diagnose the problem when the E3 or JA malfunction code appears. Let's go over what we will be learning in this course. First, we will look at in what situations the remote controller displays the E3 and JA malfunction codes. Next, we will take a look at high pressure control of the air conditioner in relation to the E3 and JA codes. Subsequently, we will learn the causes of the E3 code, the causes of the JA code, the differences between the E3 and JA malfunctions, and the methods of diagnosing them. An air conditioner uses the outdoor unit's heat exchanger during cooling operation and the indoor unit's heat exchanger during heating operation in order to release heat. This increases the pressure in the heat exchanger. The pressure rises even more if the heat exchange in the heat exchanger does not proceed smoothly for some reason. Any abnormal rise in the high pressure activates the protective device to stop the air conditioner. E3 is the malfunction code displayed on the remote controller when the air conditioner is stopped upon activation of the protective device due to an abnormal rise in the high pressure side. JA is the malfunction code displayed when the air conditioner is stopped after the high pressure sensor detects an abnormal pressure value. In the following topic, we will discuss the high pressure protection and control of R410A air conditioners. When the E3 or JA code is displayed on the remote controller and the air conditioner stops, the cause is usually a problem on the high pressure side of the air conditioner's refrigerant circuit. So, we will first learn about high pressure control of an air conditioner. This is a close-up figure of the high pressure part of the air conditioner. The high pressure sensor and high pressure switch can be found between the compressor's discharge pipe and the condenser. The high pressure sensor constantly detects the high pressure level and controls the compressor capacity in order to prevent the high pressure from exceeding a certain level. The high pressure switch is a protective device that stops the air conditioner when the high pressure control by the high pressure sensor fails to sufficiently reduce the high pressure. The condenser is a heat exchanger that cools and hence liquefies the high temperature, high pressure gas refrigerant using the air around the air conditioner. The cooling fan and fan motor are installed in order to always deliver fresh air to cool the high temperature gas refrigerant. In the event of the above-mentioned problems in the functional components or heat exchange, the high pressure rises abnormally, causing the air conditioner to stop due to the E3 and JA status. We will learn about the causes of these problems from the following page. Let's now look at the causes as to why the E3 and JA codes appear. There are three primary causes of the E3 and JA codes. The first is related to problems with the air conditioner's internal components. The second one has to do with cases when the passage of air through the condenser is obstructed by an external factor. The third one deals with a rise in the air temperature at the condenser inlet as a result of improper installation. We will now take a detailed look at these causes. Among the causes that lead to the E3 code, let's first take a look at those related to the cooling fan. The fan in the condenser is always on during heat exchange in order to deliver fresh air. If the air conditioner's fan motor malfunctions, it fails to deliver the air necessary for this heat exchange, causing a rise in the high pressure. This results in the E3 code. Damage to the fan blades also prevents the delivery of the air necessary for heat exchange, causing a rise in the high pressure and resulting in the E3 code. Let's now look at the causes related to the high pressure sensor and switch. If there is a rise in the high pressure, the air conditioner first uses the high pressure sensor to reduce it via the compressor capacity control. If the compressor capacity control cannot sufficiently control the rise in the high pressure, the air conditioner uses the high pressure switch to turn itself off, and the E3 code is displayed on the remote controller. E3 is the malfunction code displayed when the high pressure switch is activated. The possible causes are a problem with the high pressure switch itself, a loose connector between the high pressure switch and the outdoor unit PCB, or a problem with the outdoor unit PCB. High pressure control is done by the high pressure sensor. However, when the sensor detects a false pressure level, it hinders compressor capacity control, resulting in activation of the high pressure switch and leading to the E3 code being displayed. Let's now look at the causes related to a decrease in condensation capacity. One cause is contamination by uncondensed gas. The refrigerant charged into an air conditioner changes from gas to liquid, or in other words, condenses, while maintaining a certain condensation capacity in the condenser at the design pressure. If gas that cannot be condensed at the design pressure, such as air and nitrogen used for the air tightness test, is mixed into the refrigerant, it accumulates in the condenser and as a result reduces the condensation capacity in the condenser. Since there are no changes in the amount of gas discharged from the compressor, the airflow rate of the cooling fan, or the size of the condenser outlet, a decrease in the condensation capacity causes a rise in the high pressure and results in the E3 code. Another cause is refrigerant overcharge. The amount of refrigerant in an air conditioner is predetermined according to the size and length of the refrigerant piping between the indoor and outdoor units. If refrigerant is overcharged, it accumulates in the condenser. Again, in this case, the condensation capacity in the condenser decreases, causing a rise in the high pressure and resulting in the E3 code. Let's now look at the external factors affecting the condenser. The fan in the condenser is always on during heat exchange, in order to deliver fresh air. Therefore, the longer it is used, the more dirt and dust collect on the aluminium fans on the heat exchanger. As this layer of dirt and dust gets thicker, it can clog the heat exchanger, which prevents the necessary amount of air for heat exchange from being delivered to the heat exchanger, and causes a rise in the high pressure. This results in the E3 code. Even if the condenser is not dirty, there may be cases when an obstruction, such as a plastic bag, has been blown onto the condenser. This creates a condition similar to the aluminium fins on the heat exchanger being clogged, causing a rise in the high pressure and resulting in the E3 code. Let's now look at the causes related to the air conditioner installation. There is usually an 18 °F difference between the inlet and outlet temperatures of the heat exchanger, and hot air is discharged from the outlet side to the atmosphere. If the outdoor unit is not installed in an appropriate location, however, it can cause a phenomenon called a short circuit, where the hot air discharged from the heat exchanger outlet is not properly released to the atmosphere and directly returns to the heat exchanger inlet. When a short circuit occurs, the hot air discharged from the heat exchanger outlet is once again sucked into the outdoor unit. This creates an unwanted cycle where this hot air increases the heat exchanger inlet temperature, which then increases the outlet temperature, which then further increases the inlet temperature, and so on. The rise in the inlet temperature also causes a rise in the high pressure, resulting in the E3 code. Let's now take a look at the causes resulting in the JA code. JA is the malfunction code displayed on the remote controller when there is a problem with the pressure sensor, or in other words, when an air conditioner malfunctions. The possible causes are a problem with the high pressure sensor itself, a loose connector between the high pressure sensor and the outdoor unit PCB, or a problem with the outdoor unit PCB. Now, let's look at the differences between the E3 and JA malfunctions. The E3 malfunction is caused by various problems with the high pressure part of the air conditioner. Those problems include insufficient high pressure control by the high pressure sensor, insufficient cooling air delivery due to a dirty condenser or faulty cooling fan, increased cooling air temperature due to improper installation of the outdoor unit, decreased condensation capacity due to the refrigerant in the indoor unit being contaminated by uncondensed gas or refrigerant overcharge, as well as problems with the air conditioner itself, such as a faulty high pressure switch, faulty outdoor unit PCB, or poor connection between the high pressure switch and the outdoor unit PCB. Meanwhile, the JA malfunction is merely caused by problems with the high pressure value itself, such as a faulty sensor, faulty outdoor unit PCB, or poor connection between the high pressure sensor and outdoor unit PCB. Let's now learn about how to diagnose the E3 and JA malfunctions. When the E3 malfunction code appears, the first step is to diagnose the air conditioner side, such as the fan, motor, high pressure switch, sensor, and refrigerant circuit. The next step is to check whether there are any external factors affecting the condenser that conducts heat exchange at a high pressure. The last step is the diagnosis of the air conditioner installation. Note that the JA code only requires the diagnosis of the pressure sensor and PCB. First, let's learn about the diagnosis of the air conditioner side. As the E3 malfunction is caused by various problems with the high pressure part of the air conditioner, we will look at them one by one, starting with the high pressure switch. First, turn on the air conditioner to check whether the compressor starts running. If the compressor runs, skip to the second item on the next page, checking the operating pressure, because there is no problem with the high pressure switch. If the compressor does not run after the air conditioner is turned on, and the E3 code appears immediately, this may point to a faulty device peripheral to the pressure switch. If so, check whether the high pressure switch's connector on the PCB is properly connected. If it is, take the connector off and conduct a continuity test. When the air conditioner is off, or in other words, the pressure is low, the electric contact is normally in a short circuit state. If the circuit is in an open circuit state, it indicates that there is a problem with the high pressure switch. If the compressor does not run and the E3 code appears immediately, even if the contact is in a short circuit state, it is very likely due to a faulty PCB and it needs to be replaced. This said, it could merely be poor soldering, so be sure to check the soldering on the back of the PCB before replacing it. Let's now learn about how to check the operating pressure. After the air conditioner is turned on and the compressor starts running, check the operating pressure. In order to do this, attach a pressure gauge to the service port on the outdoor unit's high pressure side. The high pressure during cooling operation is usually 362.5 to 435 psi. If it exceeds 503.15 psi, the air conditioner initiates high pressure control to reduce the pressure. Assuming that the high pressure is rising for some reason, check the items on the next pages one by one in order to determine exactly why the high pressure control was activated. The first item to be checked when determining why the high pressure control was activated is the cooling fan. Check whether the cooling fan is operating properly. If not, check for any damage to the fan blades. If there is a problem, replace the fan. If not, check the coupling between the fan hub and fan motor shaft. After turning the air conditioner off, turn the fan by hand to confirm that it does not just spin freely. If the fan motor is completely broken down, a different malfunction code will be displayed. If the high pressure is high despite the fact that the fan has been confirmed to be operating normally, proceed to the next item to be checked. The next item to be checked is the pressure when the air conditioner is off. If the pressure during operation is high and there is no problem with the fan, check whether any uncondensed gas has entered the refrigerant circuit. Uncondensed gas accumulates in the condenser as a result of the pump down control conducted for several minutes after the air conditioner is turned off. If the air conditioner is left off for 2 hours after turning it off in the cooling mode, the saturation state of the refrigerant stabilizes. In this state, measure the air temperature around the condenser and obtain the current refrigerant pressure in the air conditioner using the refrigerant saturation curve. If the outdoor air temperature is 86 degrees Fahrenheit, the saturation curve tells you that the refrigerant pressure in the air conditioner is 261 psi. If the obtained refrigerant pressure differs from the actual pressure of the air conditioner measured by the gauge, this may point to contamination by uncondensed gas. If this is the case, it is necessary to recharge the refrigerant. If the pressure level obtained from the saturation curve is the same as that measured by the gauge, there is no contamination by uncondensed gas. Therefore, proceed to the next item to be checked. The next item to be checked is the high pressure sensor. The high pressure during operation is controlled by the high pressure sensor. If the pressure detected by the sensor differs from the actual pressure, the high pressure sensor fails to control the high pressure and results in the E3 code. The pressure detected by the high pressure sensor can be obtained using the graph or formula in the service manual, based on the DC voltage measured at the connector between the sensor and the PCB. To measure the DC voltage, first set the tester to the DC mode. Then, As shown in this photograph, place the tester's negative probe on the black wire at the pressure sensor's connector and the positive probe on the white wire. Either use the measured voltage, VH, in the formula, or locate it on the graph to obtain the pressure, pH, detected by the pressure sensor. Let's use the graph here. When the VH is 1.8 volts, the pH is read as 259.6 psi on the graph. This tells us that the pressure detected by the high-pressure sensor is 259.6 psi. When the VH is 1.2 volts, the pH is read as 140.7 psi, and this tells us that the pressure detected by the high-pressure sensor is 140.7 psi. If there is a discrepancy between this detected pressure level and the actual pressure level measured by the pressure gauge attached to the high-pressure side service port, it indicates a false detection of the pressure level by the pressure sensor, and the sensor must be replaced. If the gauge reads 261 psi, for example, it corresponds with the pressure level detected by the pressure sensor when the VH is 1.8 volts. In other words, there is no problem with the pressure sensor, and you can proceed to the next item to be checked. When the VH is 1.2 volts, however, the level measured by the gauge and that detected by the pressure sensor do not correspond. This indicates a false detection of the pressure level by the pressure sensor, and the sensor must be replaced. The next item to be checked is the condenser and its surroundings. Check to see if the condenser is dirty, or there is something obstructing it, and whether the amount of air necessary for heat exchange is sufficiently passing through. If the surface of the heat exchanger is clogged with a foreign object, dust or the like, the object must be removed, or the heat exchanger must be cleaned. If the surface is not dirty, and the inlet's temperature is lower than 86 degrees Fahrenheit, measure the air temperatures on the inlet and outlet sides of the heat exchanger. If the temperature difference is 59 degrees Fahrenheit or more, it indicates that the interior of the heat exchanger has gotten dusty. If so, it is necessary to clean it. If the heat exchanger is not dirty, the next item to be checked will be whether there are any problems with the air conditioner installation. The next item to be checked is the air conditioner installation. An outdoor unit must be installed in a location where it does not directly take in any hot air discharged after heat exchange in the condenser, or in other words, a location that will not cause an air short circuit. If the suction air temperature is high, check whether there is a short circuit. Also, check whether the outdoor unit is sucking in any hot air discharged after heat exchange in the condenser of another outdoor unit. It will also be necessary to check whether there is any hot air discharged from equipment other than the air conditioner. If any of these scenarios apply, it will be necessary to reinstall the air conditioner in a different location. If there is not a problem with the installation, the only remaining cause of the E3 code is a problem with the refrigerant circuit, such as a refrigerant overcharge, which will be the next item to be checked. Finally, let's learn about how to diagnose the JA malfunction. When the JA malfunction code appears, it may point to a faulty device peripheral to the high-pressure sensor. First, check whether the high-pressure sensor's connector on the PCB is properly connected. If it is, check the voltage output from the PCB in order to determine whether the PCB or sensor is faulty. In order to check the PCB voltage output, first set the tester to the DC mode. Then, as shown in this photograph, place the tester's negative probe on the black wire at the high-pressure sensor's connector, and the positive probe on the red wire. If the voltage is 5 volts, there is voltage output from the PCB. This indicates that there is no problem with the PCB. If there is no voltage reading, the PCB is faulty. Check the soldering on the back of the PCB. If there is no problem with the soldering, then the PCB must be replaced. If there is no problem with the PCB, check the high-pressure sensor side. To measure the DC voltage, set the tester to the DC mode. And, as shown in this photograph, place the tester's negative probe on the black wire at the high-pressure sensor's connector and the positive probe on the white wire. If the voltage reading ranges between 0.5 and 3.5 volts, there is no problem with the pressure sensor. If the voltage is lower than 0.5 volts or higher than 3.5 volts, there is a problem with the interior of the sensor and the sensor must be replaced. It should be noted that if the air conditioner is empty of refrigerant, this will also cause the voltage to fall below 0.5 volts. In this case, use the gauge to measure the actual pressure.